we're setting up a quad GPU powerhouse today. This is going to allow us to do all sorts of really cool AI things and other workloads, but this is so powerful because we're using server grade components. That allows us to have these 4 GPUs operating at a full Gen 4 16x speed each, one of them. And that allows us to have a massive amount of bandwidth to the 512 gigabytes of RAM that we have in this system. We also have a 7702 EPYC on this server grade motherboard, and that gives us 64 cores and 128 threads. We have some super fast storage that we'll be able to load models from and save data to that we're processing. This is a pretty decent rack. I'm going to show you a lot of quirks. I'm going to give you a lot of steps and tons of tips and tricks along the way that helped me get this set up. As you can see, this really nice 420 millimeter radiator. This is a good design. However, they don't come like this out of the box. So I'm going to show you the mounting positions and what I did to get this in here. I hope you're excited. Let's get started. The Gigabyte MZ32 AR0 comes in 2 versions, version 1 and version 3. Both of them have BIOS updates and drivers that you'll definitely want to check from the Gigabyte website. There are other options out there like the H12 SSLI. It is a smaller format board also, so it can fit in a wider variety of locations.
To go over some of the benefits of using server grade boards, I will quickly mention you get access to, of course, the vast amount of PCIe lanes that the Rome generation at Gen 4 speeds, up to 128 of them, provide. And the MZ32 AR0 is a great board for being able to use this. It gives you 4 full 16x slots. However, there is one big catch, and that is these 4 slim SAS need to be connected to these 4 slim SAS with a physical cable to be able to use this topmost slot. Something I did not know when I bought this, but I do have those cables on the way, and I'm sure that there will be some additional content around that when I get those connected. Right now, I'm actually, one of the GPUs is on an X8 slot. The other 3 are on an X16. These 2 slots down here are for Gen 3 speed devices, an 8X and a 16X. Now, this 8X slot here is eventually going to be 2 NVMEs that are U.2 NVMEs and a carrier card that I have, which will be very performant as I move the final GPU up here. It has 2 M.2 slots, which are usable without sacrificing any of the other components' connectivity. And the nice thing is you get 16 DIMMs. This allows you to scale up to whatever amount of RAM you're looking at very cheaply, because you can buy lower density DIMMs instead of higher density DIMMs, which are of course going to be significantly cheaper. It does have an OCP 2.0 mezzanine slot on it also. Networking usually is what is connected via that. If you need to have high performance networking, I'm going to actually use the PCIe slots down here for either 100 gigabit, most likely 100 gigabit, or 40 gigabit connectivity. But for the price, this is a very attractive package with a 7702, which is a great processor also. It is among the most affordable ways to get 4 full Gen 4 X16 lanes.
And while I chose a quad 3090 setup for the rig that we're building today, I also have a dual 4090 rig, so we can get some information and compare possibly some interesting data points, see what kind of performance we're looking at between the 2 of these systems. It's one of the most popular questions out there, so I should be able to answer that pretty effectively. 3090s are an excellent choice for a GPU for an AI rig because of their massive 24 gigabytes of VRAM and the fact that they are very cost effective, coming in at about $650 a piece for these. Now, they were quite dirty and the pads were insanely old, so I had to repad them and it was a good time to clean them. Let's take a look at what that looked like.
The level of effort and cost that will go into repadding and cleaning your GPUs is not trivial. You're going to want to have a fairly decent amount of space. I chose to go with some top-of-the-line critical pads for the repadding, and those are not cheap either. Factor in about $50 and about an hour of time for each GPU. We are using 2 different types of thermal paste, Arctic MX4, and also another very well-revered, but we're going to find out whether or not it lives up to its claims, thermal paste. And this is a messy operation. Do take your time. Don't expect it to go fast, but definitely have a good work area to start with going into this. And with the padding and the pasting done, and we should have a GPU that can stay within its thermal bounds, better possibly than even it could stock.
The server motherboard route, you could also go with something like a workstation motherboard, but going the workstation route is actually quite a bit more expensive than what you're going to be able to afford and get. The performance is going to be very similar between the two. So a server motherboard kind of layout is going to be a little bit more cost effective. Also, one of the reasons I went with the 3090s is because these really do make probably the best economic sense right now, given that the 50 series is going to be coming out soon, and these are about less than half the price of a 4090, and they still have that 24 gigabytes of VRAM that can be shared amongst all the cards and pulled together by some of these distributed applications that are able to make use of the NVIDIA Container Toolkit effectively. I'm going to start from building it from the bottom up, as that's where the least amount of modifications happened. So the lower assembly and putting on the side supports should be how you start with the assembly of this rack. Now there is going to be a side that has an opening on the bottom and a side that does not. If you note here, you don't see a cutout, and if we come around here, you do see a cutout underneath the mezzanine slot. So that's a good way, if you do go with this combination, to orient this. It will also line the screws up as good as possible right off the bat. And you will have all the way up to your ATX screws aligned on this. However, when I got to the rear screws here, since this is a large format server board, you're going to need to tap 3 screw holes here. It's not that bad, but I would urge you to put some sort of a locking adhesive on the screws once you put them in. I did that on all of these. So the PSU is situated on its side. I have a Corsair HX 1500i. You should go with a 1600. However, I'm also going to be doing manual limiting. Essentially, they won't be getting but about maybe 275 to 250 watts each, but they'll still be able to perform quite well. You could also add a second power supply, but you would need a balancer, and you would be able to put that over here on this side. This is good to attach, and then you attach over here. There's not any really other attachment points, but everything is fairly firmly in place. The standard connector for the power works just fine on this, and also you've got your 2 CPU power connectors. The Corsair does work because also it has 4 cables that are included with it for PCIe power, and each one of them breaks out into 2 8-pin connectors for PCIe power. There is still room if I wanted to put some additional accessories on here. So with this PSU on its side, this was not able to rest down here without this bar intersecting the PSU top. So that wasn't going to work. I did end up having to also drill new screw holes here. I think you're going to have to as well. The reason why is because these PCI risers are firm. To do this and to make this all fit, I had to raise this up so the bottom is actually connected with a screw on each side, and that is on both sides. This comes with 2 mounts. We're going to talk about the water cooler mount last. And so you can see that I did have to adjust the height that I have this mounted at as well. I was able to use the existing screw hole for that, which hopefully that helps you out, because that took me a fair amount of time to figure out this specific arrangement to get everything in here. This is actually built for 2 rows of GPUs. However, you're only going to be able to fit 1 row of GPUs and use the parts that it came with. For the price, I think that's an acceptable trade-off. These are, after all, pretty cheap. The other cross brace is actually the support. I flipped it upside down, and it's actually the support that's running side to side to hold the base of the water cooler. And the other crossbar that I had here has been attached to the top. Now this allowed me to retap screw holes here and here and here and here, which I did have to redo both of those, and then mount this up here. Then I was able to put the water cooling block in and set this down, attach these, And each one of these fans actually is slightly above and below the brace. I don't know if you can see that. I think you can see that pretty well. They go above and below the bars for each of these fans. I used a lot of zip ties to make sure things were cleanly held up and the cable attachments to the system were cleanly held. So I used a Corsair water cooler that is an AIO. These are something you can find. They're 420 millimeters. Check the links in the description below for all of this stuff. This allowed me to actually get really good coverage, and they do make an SP3 bracket for it. So with that SP3 bracket and the standoffs, you'll be able to put the just pretty stock cooler on there. And the thermals are working out really well. A water cooler for this setup is going to be perfectly adequate, unlike my 7995 WX, which apparently nothing in the world can keep cool. If you look at these, you will be able to tell that there's another tip here that sucks kind of. You're gonna need to drill out a hole here that's bigger to be able to fit in a screwdriver, possibly, possibly not. But I also had to drill out a hole on these and find custom screws that luckily I just happened to have laying around. They were actually hard drive thread screws from a fractal defined Meshify for putting hard drives into the caddies that I used to tie this in to the water block's pre-drilled mount points. This gave me just enough room to get the water cooler down here. If you look here, this has ample room. This one is kind of a little bit tighter than I would like. If you have better ideas on that than what I just expressed, let me know. This is gonna be a little bit trial and error. I don't wanna blow really cold air directly onto it because I don't wanna form condensation, but I also still wanna get some benefits of the cooling as much as possible. Check the link below for the written guide where I will give you a little bit more information on all of this stuff also, because this is fairly complex. I think this isn't that bad if you're looking. This is idle wattage right here of about 200 watts, and that is with all of this. And that is setting in Ubuntu right now, which there's no workload going on, but it's able to maintain a pretty decent idle for this much hardware. If I look at how much the idle is on, say, the T620 with all of its SSDs, NVMEs, and also array of high performance networking and storage cards in it. Yeah, so it's 252, and the R720XD doesn't have a display on the front of it for me to be able to check, but it's probably in the couple hundred range also. Now consider that these are running 2667 V2s, that's 8 cores, 16 threads apiece, but 2 processors, 16 cores, 32 threads. We've got one machine over here that has more capacity for CPU and way more for GPU, and at better generational improvements as far as speed in this machine. That's why this makes a lot of sense in my opinion, and I think it's going to be so good for so many types of workloads. It'll allow me to shut down some of the less efficient machines as well. So in conclusion, we have built a quad GPU, AI, and other workload powerhouse. Let's take a look at what the cost was.
So the cost of this entire build altogether is right around $4,700 as of this time. And there are some of these items that might vary and you may be able to find better deals on. So I'll point those out really quickly, and there are a couple of options. Actually, this is, I was able to find this in 2400 speed, so that's actually what's linked right there, and it's a full kit of DDR4 64 gigabyte DIMMs. One of the reasons to get the 64 gigabyte DIMMs is that if you wanted to expand and double, you could go to 1 terabyte of RAM in the system instead of 512. If you go with 32 gigabyte, then you're going to need 16 to get to 512. You do not have to hit 512 either. This is just what I had around, and so I tossed it into this system. I think many people should match up their RAM for the size of their intended workload, and while I can't give you an answer as to what I think that looks like yet, that is something that probably does vary quite a bit, and hopefully we can get some answers. Like I mentioned, make sure you hit that like and subscribe, ring that bell so you get notified when we have more content on these topics coming out. The PCIe risers, I would recommend getting all the same size, all the same length. The 7702, a 64 core processor for under $600, kind of crazy, but this is not something you would have to have. I would recommend not going lower than 32 cores, but if you had a 48 core or a 32 core, then I think you're going to be okay. You're going to want to try to make sure your CCDs are optimized so that you have at least 6 or 8 CCDs, as there are 8 channels for RAM. The ICU H150i, this is just one of the very few water coolers out there that does have a compatible plate, the Corsair SP3 adapter that I linked here. So you can adapt this to a SP3, which is the same as a TR4. So this will say TR4 on that page, but the Epic version is the same, essentially pattern layout as the SP3 TR4. The Arctic MX4 paste that I got here goes on sale quite often. I would recommend, trying to go with something quality for this because especially on your GPUs, you do not want to have to crack them back open. There is another brand. I'm going to actually have a separate video that will be head-to-head in GPUs, 3090s, among the hottest GPUs on the market. The Arctic MX4 going up against a mystery competitor that is highly revered. So definitely that's one to look forward to. I mentioned I have the 1500i, and so this is the price as I have all the stuff here. But I would actually recommend going with a 1600 instead of a 1500, and the price is pretty much right in that ballpark. Here's one thing that was not featured in this, and this is the connectors. There are 4 of these connectors. These are like a straight shot connector that go from the 4 NVMe U.2 connectors to the top SAS 4i connectors above slot 7. That is needed to make slot 7 enabled and get full 16x. So you do want to factor that into the cost of the motherboard, and that is essentially about an extra $42 there on top of the $388 for the Gigabyte MZ32AR0. Still the cheapest, but when you factor in $41, you're at about $420. And at $420, you start to become a little bit closer to where I've seen the H12 SSL boards dip down to. I would recommend going with an H12 SSL variant if you can find one for the $500-ish price range. I think that's very, very comparable. I think the Gigabyte MZ32ARO is a great option if you can't find that. And the version 3 and the version 1, it doesn't really make that big of a difference between them. They're both, for this task where we're going to be doing, essentially going to be the same. The MSI Ventus 3090s that I have here, those can be as low as $650. They can go up to about, I think right now they're about $720, but you can find various other quality brand manufactured 3090s. You would want to factor in whether you are probably going to need to repad them or not. If you do end up repadding, which that may or may not be something you needed to do, these prior 3090s had been used for Ethereum mining in an open air environment for quite some time, and they had, of course, collected quite a bit of dust on them. So it was definitely time for a good detailed cleaning on them and a good detailed repadding. Of course, that is running a workload of nearly 100% on them. So those are very hard used. You may get some very pampered if you can get 4 of them together that are pampered. You don't need to factor in cleaning or repadding or anything like that, quite likely. So that's pretty much it. I would say you would be safe to say in the $4,500 to $5,000 range would be what you would expect for a quad GPU 3090 build. This is the cheapest that I can think of that you'll really be able to do it until you start, cutting down on things like the 7702. You're going to save maybe $100 or $200 here or there, but pretty much your big base cost is going to be the GPUs that you use. And while $650 may seem like a lot, we're still at $1,150 to $1,300. Quality 4090s are not cheap. And with the 5090 series right around the corner, I would be wondering what happens to the price of 4090s in the next couple of months here. I've got 2 4090s, and I might be looking to pick up a couple more also. We'll learn together what we can expect out of the system. So That's going to be exciting, and I hope you're excited for it. But yeah, somewhere around 4,500 to 5,000.
And so this budget range, I would classify this as higher end. We're going to have a couple of other smaller builds, one very budget, seeing how cheap we could do something. And this will allow us to see a top end performance versus a middle tier performance and a lower tier performance that come in at roughly half of the price of each other. We'll see how cheap we can get the lowest tier down to, though. I think that we might be able to, in the $500 range, have a fairly decent system. That's kind of a challenge that I've got. In addition, we're also going to be diving way deeper on the software aspects of setting it up, what we're running, what kind of performance it looks like, and how fast we're able to process things. So make sure you hit that like and subscribe so you get notified when that kind of content comes out. Take a look at how long it took to put this system together.
So as far as actually going through the steps to assemble, I think you're looking at right around maybe 7.5 hours, probably a 8-hour thing to get this all done if you have to go through the GPU disassembly, cleaning, repadding, and reassembly, which will take about an hour a piece once you get good at it. The first one will kind of be pretty slow, actually, and then it'll kind of go much faster after that. But it'll probably even out to be right around an hour a piece is what I think I would be able to do one in. So that's 4 hours of time right there. So you're looking at either about 3.5 hours if you don't have to repad, or about 7.5 hours if you do. Definitely also make sure you are in a large area with maybe a magnet or something that you can put some of the screws on so you don't lose anything. Pretty important. But the rest of these tasks, I think this is a fair estimate, and I think you could wrap it up even if you did have to go through all the GPUs, and it might be a good idea if you're going with 3090s. Get this done easily in about 8 hours.
And I hope you've enjoyed journeying with me as we set up an insane quad GPU rig. Now, if you're interested, you should check out some more of the insane videos this channel's done on things like insanely high performance networking, which we'll be using with this machine very soon. Everybody have a great rest of your day. I'll check you guys out next time.